Alright, today we're going to have a look at this theorem. The external angle of the cyclic quadrilateral is equal to the internal opposite angle. So I've got labelled here in green, okay, the two angles in concern. This is the external angle of the cyclic quadrilateral. Okay, it's labelled 120 degrees at the moment. And the internal opposite angle, or the angle that's furthest away from the external angle, is the other angle that matches. So what we'll do, we will change those and just see, alright, that both remain the same. So as I change the size here, you can see that at the moment they're both showing 120. And of course you know it's a cyclic quadrilateral because the vertices of the quadrilateral, okay, touch the surface or circumference of the surface. So changing them slightly, alright, you can stop it at any time and see that the external angle is always equal to the internal opposite angle. Now, why does that work? Well, in order to show that, I'm going to need to put in some construction lines, and that's there and there, and I will just start with this angle here, say 120 degrees, and now I'll work out what the size of this angle here is. So with 120 there, this angle here will be 60 because 120 and 60 will add to 180. So we'll label that angle now. So that's 60. Now, think of that angle there as having an eye, like a side view of a person's eye. Looks like that. It looks out and sees this purple arc here, and you'll see that it's standing on that 60 degrees, got two legs, it's standing on either end of that purple arc. And the angle at the centre has got an eye here. It will be twice as much as 60, it'll be 120. So I'll put that in, 120 here. Think of it as having an eye, and it looks out and it sees that same purple arc there too. Alright, now that might be obvious, but when we do the reflex angles, it's not quite so obvious. So now I have the angle at the centre being 120, so this angle here has got to be 240 because it plus the 120, I've got to add the 360 or a revolution, so the angle's at a point. So put that in, 240 degrees here. Now, using the same process of that being the side view of the person's eye, it looks out and it sees this green arc that travels from one leg, looking down here, it starts here, it goes all the way around there, right, it stands on that green arc all the way around there. And now if that's 240, this angle here has got to be half as much as that, so it's got to be 120. So get Josie to put that in, 120, and you can see it's got an eye here that's looking out at too. It looks out and it sees that same green arc, and that green arc is all the way around there. So you can see, should be able to see that the two purple labelled angles stand on the purple arc, and the two green labelled angles stand on the green arc all the way around there. Alright, now as I change one, you'll notice that they all change. Alright, I'll move that one around a little bit. This one here I just happen to stop on a perfect 90 degrees, but I can make it go up higher. Alright, bring it all the way up to the top, bring this one up a bit too. Alright, and then I can stop it at any point, and there's not a bad place to stop it, okay, and just check the internal ones. Alright, so because that's 50, this angle here has got to be 130, alright, because 130 and 50 add to 180. With 130 there, double that, the angle here that matches with it's 260, and then 260 and 100 add to 360, so half 100 then is 50, and consequently now you can check and see that the external angle, that's that one there, is equal to the internal opposite one. So that's the end of the show. Now you could keep doing that, but there's no point. We're going to now move on to the proof. Alright, so what we'll do, we'll rub out those angles there. I'll just get it back to a nice symmetrical look, and we'll move on to the proof. So rub those angles out, put the proof in. Now the proof, as you probably realise, relies on the previous theorem that we had a look at, namely that the angle at the centre is twice as much as the circumference. So we'll put that rule in. Previous theorem, the angle at the centre is twice the angle at the circumference when standing on the same arc. So we proved that previously, we're not doing it here, but we need that in order to prove this particular theorem. Alright, the external angle of the cyclic quadrilateral is equal to the internal opposite angle. And so I'll put it down there once so I don't have to keep writing it down, and I can just refer back to it. So I'll put in our first line now. That is that angle ABE is equal to alpha. Don't need a reason for that because for the purposes of explanation, I'm just letting AB equal alpha so I can follow it on the diagram. Now, the next line I do need proof for, or reasoning for, because I'm going to call this angle here 180 minus alpha, and the reason being that that's 180 degrees all the way around there. Those two angles, therefore, are supplementary. So putting that in, CBE is equal to 180 minus alpha, supplementary angles. Those two are supplementary. And then, because that's 180 minus alpha, right, think of that eye again, looks down, sees that purple arc there, and the angle at the centre that looks down at that same purple arc is this angle here. Alright, and so it's going to be twice as much as that, so it's going to be 360 minus 2 alpha. So put that in, 360 minus 2 alpha, and I've got to put a reason in for that as well. And it's that reason up there, that saves me writing it out again. Alright, so 360 minus 2 alpha, what's this angle here going to be? It's going to be equal to 2 alpha, because 2 alpha, well, plus 2 alpha in particular, plus 2 alpha plus the minus 2 alpha will cancel each other out, and I'll just get 360 degrees all the way around there. So putting that in, there's my 2 alpha, and I've got to put a reason in for that. COE, okay, COE is equal to 2 alpha, angles at a point. Now if it's 2 alpha here, right, use that eye process again, that eye looking out on that green arc. What angle at the circumference also with an eye looks out and sees that green arc? Well, it's going to be this angle here, right? And it's going to be equal to alpha. So put that in. There you go. There's the eye. Looks out, sees that green arc there. Must put a reason in for that again. And again, it's this theorem up here. The angle at the centre is twice as much as the angle at circumference. Okay, when they both stand on the same green arc in this case. Now I'm just about finished. If you look up here, you'll see that ABE is alpha. ABE is alpha, that's there. And this angle here, CDE, is also equal to alpha. So these two angles, ABE and CDE, must be equal. So put that in. Okay, the theorem above has been proved, namely that the external angle in a cyclic quadrilateral is equal to the internal opposite, the one furthest away. Okay, those two angles are equal. Good, thank you very much. Don't forget to like and subscribe.